Okay, let us start to discuss about chapter 3 about wave. Okay, there's few things we need to discuss. The first thing we need to ask, what is wave? What's the difference between them? So there's two main type of wave. We call it a transverse wave and a longitudinal wave. Okay, a transverse wave, usually a transverse wave, the wave propagate is perpendicular to the particle movement, or you can say particle movement of a medium move perpendicular to the direction of the wave propagation. Okay, this one I think you know already. And if longitude the wave is going horizontally like this lah, and it will start to speed again, something like that. Okay, and if you look at the graph, you can understand that the longitudinal wave, for the peaks and the trough, for example, peaks is over here, or crest lah, not peaks lah, the crest of the transverse wave is also the compression of longitudinal wave compression. Okay, I think it's one S lah, but it's okay. And the trough will be the rarefaction lah. Okay, so this is the main basic thing, and this is the amplitude, very easy, amplitude. And this one is a wavelength. Okay, or here is also wavelength, and one cycle we call it a period. Period means how many seconds it took, how many seconds for one cycle. Okay, we call it a period, and we call it a frequency. Is 1 over f, or f is 1 over t. Okay, it's the same. So frequency is how many cycle per second. Okay, so that's the difference between two of them. Okay, so if they want you to do the explanation or what's the difference between transverse wave or longitudinal wave, you can talk about how the particle movement is perpendicular or parallel, is a crest and trough, compression, rarefaction. Example have light wave, light EM wave, or the EM wave is transverse wave, and this one will usually talk about sound wave. Okay, usually talk about sound wave. That's the main difference, main example of two of them. Okay, so that is it. So what is how wave, what is the, what would we say that, the characteristic of a wave. Okay, characteristic of wave, I have three. So one is reflection, the second one is refraction, and the other one will be diffraction. Okay, so reflection is mainly when there is a medium. Okay, and when the light travel, this is not good, let me draw a 90-degree lah. So here is a 90-degree. When the light travel through this angle, the reflected ray will have the same reflected angle with the incident angle. So this one is the incident angle, and this is the reflected angle. So reflection will be incident angle equals to reflected angle. So that's reflection. Okay, sometimes they usually like to draw not like this, but they draw like a wave, like a line or wavefront. Okay, then you need to figure out what is the line should look like. So maybe it's like this, and the propagation will be exactly like angle and angle. The angle and angle must be the same lah. So it's all reflection. So other than that, what is a reflection? Okay, refraction, okay, is a bending of wave lah from one medium to another. Okay, so bending of wave from one medium to another. So the important part is different medium. Okay, different medium. For example, here is a medium over here, and you can see this line over here like this. Okay, so usually this one is air. Okay, so air have n of 1, and this one is someone lah, something like maybe 1.3 is glasses. So when these go in, we call it incident angle. normal is the angle between the normal and the incident ray, and it will reflect again. It's either go in or go out. Okay, so how we know it's go in or go out without knowing something more detail? Okay, we can think it's like this: when we in air, the light, some things travel more easily lah when in air. Okay, but when they go into a medium, there's a lot of particle like blocking the wave, causing it to become slower or going towards going towards the normal. So going towards normal. So if there's a higher density of a medium, you will actually bend the wave more lah. But if it's less than the air, okay, it's quite hard, okay, you will bend further away lah. Okay, so usually it's like that. So we can have a formula, we call it the refractive index is n equals to sine I over sine r. Okay, sine I over sine r. And the other thing we also know is about the critical angle. A critical angle is only applicable when it's from a denser medium. Okay, for critical angle, it's usually from a denser medium. Okay, must be a denser medium. So a denser medium, okay, for angles, for example, like here, when the critical angle is 45 degree and it hit exactly 45 degree, it will actually go in straight line like this. Okay, if less than 45 degree, I mean more than 45 degree, okay, more than 45 degree, actually return back. But the return back, the angle must be the same lah, huh? Critical angle, the angle must be the same. Means I and R will be the same. But it's less than, critical angle, you just go out lah. Okay, I think it's further away because it's much less than lah. So much less than, you going further away. So this is how it is lor for critical angle. But sometimes they don't use the angle. They give you like what is the speed of air and speed of medium. So we know that speed of light is actually is a constant. So speed of light 3 times 10 to the power of 8 is the constant, and divide by speed of medium. So important when we write it like this, we know that the medium is one that inside here and the light is one that's outside lah. Okay, so this is how we usually do it lah. So other than from light from less dense to denser medium, like if from less dense to denser, it going to the middle, going towards normal, or dense to going to a going to a denser medium will refract towards the medium. Okay, dense medium reflect towards the medium, but less dense moving away from the medium. Not only we have this, we also have deep water and shallow water. Okay, again, is deep water, the wave can travel more freely because there's nothing blocking. So when it's going into the shallow, you need to draw a normal line. Then this normal line. When you go into the shallow one, it's actually bent towards. So it's towards like this. So you can have an angle like this. Okay, bends towards, and it's shorter wavelength. Okay, because speed is getting slower. Okay, speed is getting lower, wavelength is also lower. Okay, because speed is actually equals to f lambda. Okay, this is another formula. Okay, so you need to know the scenario lah, huh? Bend towards medium or bend away from the medium, shorter wavelength, longer wavelength, something like that. Okay, okay. And the last one is diffraction. Okay, diffraction, we also have some criteria, okay, to affect the diffraction. For example, if when there's a blockage over here, we are going to go diffraction, so we just normally like this lah. Okay, so diffraction don't affect the frequency, but in fact all of it doesn't affect the frequency, only affect the wavelength. Okay, but for this one is like this. Okay, so when bending, what's affect the diffraction? So if bigger wavelength, number one, bigger wavelength. Okay, then bigger diffraction. Okay, second, narrow gap, bigger diffraction also. Okay, or you can say faster, if you faster, then less diffraction. Okay, so usually it's like this lah. Okay, for the first section we all learn is about this. Okay, major usually what's the difference between transverse and longitudinal, and the characteristic of what is the effect. What wave does affect by what? So refract, and diffract, like the characteristic of them. So usually it's like this for the first part. Okay, so that's it.